In 11.5, it's going to be more quadratic formula for the first 4 problems. The only difference on those first 4 problems with the quadratic formula is they're going to expect you to round to the nearest tenths place. Our calculators do not have a plus or minus key, which means you are going to have to input each one individually. I'll give you an example. You're going to put one of them in with a plus sign, figure out what that is as a decimal. You're going to plug one as a minus sign, and then figure out what that is as a decimal. And I recommend using the fraction button, which I will show you as a part of this class. After that, questions 5 through 12 are all going to be questions that are in standard form, and you need to convert them into vertex form by completing the square, which comes from 11.1. Couple reminders that come from chapter 10. The vertex is opposite same in HK, and the axis of symmetry is x equal to h. And then 6 through 12, when you're completing the square, don't forget to factor out that GCF. That's a reminder to you, because some of these problems are going to be dealing with word problems. And every single word problem, if you think about a maximum or a minimum point of a parabola, the highest point is going to be the place where you would have the maximum or greatest profit or yield, or the greatest height, or the greatest cost or distance, depending on what is graphed. So all of our word problems that we have to do will end up being parabolas, and finding the vertex will help us find the best max or minimum or greatest point or least point. So we have 3 examples, 1, 7, and then I picked all of 10. 10 is huge, so we might as well do the big one, okay? Number 1 has 3x squared minus 10x minus 8. Solve using the quadratic formula. Simplify answers to decimal form to the nearest hundredth. So the first thing I do is I either say this is A, this is B, this is C. And then I start plugging things into my quadratic formula. Negative B, opposite of B, plus or minus radical B squared minus 4 parenthesis A parenthesis C all over 2A. And so literally, I will plug this in separately in my calculator. I'll plug in 1 with the plus sign, and I'll plug in 1 with the minus sign. I use the fraction button. Since I teach with the Casios, I am going to show you what my Casio looks like. I'm just going to type this in first before I show you. Plus the square root of 100 minus 4 times 3 times negative 8 over 2 times 3. Just to show you with the Casios, I press the fraction button and I type in 10 plus 100 minus 4, and I put times 3 times, and then I use the negative button for negative 8 over 2 times 3. Sometimes it'll come out to a nice whole number. And then, because I typed this whole thing in, and my equation is only different by this minus sign, sometimes what I do is I take my calculator, go up, and I edit the problem I just did, delete, and I put the subtraction sign in there. That way I can figure out what is it rounded to the nearest hundredths place. Negative 0.6 will round 0.67. So definitely we're using calculators here. I believe that you might have an imaginary number on number 2. If you do, I don't think there's a way to convert that to a decimal. So number 2, I'm giving you a warning. I believe number 2 comes out imaginary. So just leave that as your final answer. Don't worry about switching it to a decimal. But then we get to the harder ones like 7 and 10. 7 and 10 say find the axis symmetry and the vertex for each parabola. You're going to treat this just like it's y equals. Doesn't matter if it's f of x or g of x or anything else. You're going to pretend this is still a y equals all that. You're going to subtract the 5 to this side because we need to complete the square. Leave an underscore. Because the a value is a -2, we need to factor out the -2 even from that 4x. -2 times a -2x would be a 4x. This is what I was warning you about on numbers 6 through 12. If the a value is not 1, you have to factor out the a value from the a and the b. The b has to factor that out as well. Then what we're going to do is we're going to fill in these underscores with something with half of b. Half of b squared is plus 1 squared. But we're really not just adding 1, we're adding the GCF times the 1. So over here I write -2, because that was a -2, times the 1. That little thing right there is where most students make the most common mistake. But you're smarter than that. You're not going to make that mistake. -5 minus 2, y minus 7. Over here, this is going to factor. That's the whole reason we did it, is to be able to put it into vertex form. To get to that -2, we have to have a -1 times a -1. Which means that in vertex form, if I add the 7 over here, then I know opposite same is my vertex. 1, 7. That's my H, that's my K. Just like we did in chapter 10. Our axis of symmetry is x is equal to h. Well, what's the h? The h is 1. It's the x coordinate of your vertex. And what we did here is the same thing we're doing on all the other problems to find that maximum or minimum point. So don't freak out, because this is the kind of math that we just did called completing the square. We're just doing it for word problems as well. Like number 10. Number 10 is a big problem. And some of you, when you read it, you'll just freak out by the enormity of it. There's parts A through F, Mr. Paramo? Yes. There's 6 different parts. 1, 2, 3, 4, 5, 6 different parts to that question. It's because this is the kind of math that they use in real life. A ball is thrown vertically upward with an initial velocity of 48 feet per second. If the ball started its flight at a height of 8 feet, then its height, h, at time t can be determined by the function h is equal to -16t squared plus 64t plus 8, where h is measured in feet above the ground level and t is the number of seconds in flight. Who uses this? Physicists. People who are trying to calculate where a rocket might land, or people who are doing measurements of where things would be or what the path would be like. This is something that you guys could do too with this kind of math that you know. But the first thing we do is we have this equation, and t represents the time that it takes for an object to travel a certain height. What is the height of the ball at 1 second? What that means is, if you plug in 1 second here and 1 second there, what will h be? All we have to do to find out the height at 1 second is plugging in 1 in for that equation. Negative 16 times 1 squared plus 64 times 1 plus 8. What's the height at 1 second? For me, I'm going to use a calculator. But I know what negative 16 times 1 is. Plus 64 times 1, I know what that is. Plus 8. But I'm going to do negative 16 plus 64 plus 8 on my calculator. So the height is going to be, that's what I plugged in, 56 feet. How did I get it? I plugged in 1 second into the formula to figure out what the height would be at 1 second. The next question says, what's the height of the ball at 3 seconds? What do I do? Same thing. Same formula, except at 3 seconds, we plug in a 3 seconds plus 64 times 3 plus 8. Well, I don't know what that is. Well, I'm going to plug it into my calculator. Negative 16 times 3 squared plus 64 times 3 plus 8. What I like about these calculators is that I can check, did I type this in the same way that it's written on my board? And I can look and I say, yep, it is. Looks exactly the same. And what do you know? The height at 3 seconds is 56 feet. That's because the object went up 1 second to 56. It must have gone higher, and then at 3 seconds it's coming back down and it's at the same height, because the object isn't going to stay at 56 feet the whole time unless it got stuck on top of something. Part C. What's the maximum height the ball attains? That would be the vertex. If you think about this object doing something like this, the maximum height will be the highest point, otherwise known as the vertex. So let's take this and let's complete the square on it. I'm going to zoom in just a bit so you can see that. I'm going to subtract the 8. I'm going to leave an underscore. Subtract the 8. I'm going to factor out, I need the A value to be 1. I need to factor out a negative 16, and I need to factor out a negative 16 from 64. 64 divided by negative 16 is negative 4, by the way, just in case you didn't know. And this is what you're going to have to do on numbers 7 through 12 anyway, so you might as well learn how to complete the square on it. Once you're here, here's your B value. Half of B is negative 2 squared. But we're not really adding 2 squared, we're adding the negative 16 times the 2 squared. So over here I put negative 16 times the 4. 2 times 2 is 4. So I'm going to work this out. Negative 8 minus 16 times 4. Negative 8 minus 16 times 4 is negative 72. Over here, this side factors perfectly. It's pretty much in vertex form. All I got to do is move the 72. What's nice about this is that once you get here, now you know exactly how much time, opposite, same, it's going to take to reach that maximum height. It's going to take 2 seconds to reach a maximum height of 72 feet. Then what this actually says, when does the ball hit the ground? When is the height equal to 0? So if I were to take this equation here, and I put 0 minus 72 equals negative 16t minus 2 squared. If I were to take this piece, bring it down, and put a height of 0, and I want to find what time will it take to get that height? All I have to do is divide by negative 16. 72 divided by 16 is 9 over 2, or 4.5. Square root. It's about 2.12 equals t minus 2. Technically, there's two possibilities here, a positive or negative, but we're not going to use the negative value of time. So if I do 2 plus 2.12 for my time to the nearest tenth, that's going to be about 4.1 seconds for the time to have a height of 0. Super complicated problem, but if you think about what we're doing here, we're learning the kind of mathematics that leads into physics 1. It leads into calculus chapter 2. Just so you know. Then it says sketch the graph. Okay. 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. At 1 second it was 56 feet up. 2 seconds it was at 70 something, 72. Label the y-intercept on the graph. Here's the y-intercept. Why did I start there? Because in the problem, it says the ball started its flight at a height of 8 feet. Starts on a hill, or maybe it's on a table or a ladder. I don't know. Or maybe that's where the spring is. I'm not sure. The y-intercept, what would the y-intercept represent? 8 feet is the starting height. So in all the problems that you have on this worksheet, completing the square helps you find the vertex, and that vertex is the maximum point that you're going to be looking for. With that being said, that's where I'm going to stop your notes.